Hello and welcome to Wagner Academy. It's time for a little lesson in logic. This is Geometry 2.2. These are the terms you should know by the time we're done with this lesson. I imagine there's going to be a lot of new looking material for you. Don't worry, it's not difficult, it's just new. So you're just going to have to think it over a little bit more, but I think it'll come pretty easily once you get the hang of it. And as always, make sure if you're one of my students, use those extra examples in your book. Oh, the nostalgia is just flooding through my veins, coursing through my veins right now. This used to be my old college logic textbook cover. There is actually an entire semester course that you can take on logic. You can even, at some schools, I'm sure, major in logic and have a whole degree in logic. But we're just going to look at pretty much one lesson. The next lesson, 2-3, deals with a little bit with straight up logic as well. But this lesson specifically is logic and some symbols we can use in logic. But let's get started by filling in all these blanks. So a lot of new terms here. We're just going to quickly go through what these are and then put them into practice, see what they look like used in different examples. So a statement is any sentence that is either true or false, but not both. The truth or falsity of a statement is called its truth value. So truth value. Statements are often represented with these two letters. These are the most popular, just like X and Y are the most popular variables in algebra. P and Q tend to be the most popular statement letters in logic. And the negation, so that's the negative, the negation of a statement, has the opposite meaning as well as the opposite truth value. The negation of a statement P is not P. So if we write it out in words, it looks like that. But we have symbolism for a lot of things in logic. We have this tilde is used as a way to say not in logic. So this is read not P. Two or more statements can be joined together to form a compound statement. You've probably heard of the word compound before, so that's putting things together. Two or more statements is a compound statement. A conjunction, and more nostalgia coursing through my veins. Conjunction junction, what's your function? Look it up on YouTube if you're wondering what the heck that's all about, and you might have a song stuck in your head for the rest of the day. It is a compound statement formed by joining two or more statements with the word and. So we put two things together with conjunctions with the word and. The conjunction of two statements P and Q is P and Q. Or in symbols, you can say P, and then in logic we use this. It looks like a capital A without the line through it. And that's how I remember that this goes with and, because it kind of looks like a capital A, and starts with A. So we have P and then that symbol Q. So this is read P and Q. And finally, on this page, a disjunction. So I think of things that are disjoint, that are kind of separated. That's more what this is like. Conjunction, where things are together, compound, and. This is with the word or. And the disjunction of two statements P and Q is P or Q. And in symbols, it's P, and then it looks just like this, just upside down. So it ends up looking like a V, like a capital V, sort of. So P or Q is how you would read that. Moving on to the next slide. A conjunction is only true when all of its statements are true. So if there's just two statements, then both have to be true. If there's three statements, all three would have to be true. If there's 10 statements, if you had a 10-statement conjunction, crazy, they would all have to be true for the whole conjunction to be true. So let's take a look at some examples. Example 1, use the following statements to write a compound statement for each conjunction, then find its truth value. So statement P is this statement. A heptagon has 7 sides. Is that true or false? If you don't have a different color, I would highly recommend getting a different color for this lesson so that you can write some stuff in your normal, hopefully pencil, and then write some things in addition in a different color so that it stands out. I think that's going to be really helpful on this one. So whenever I use red, that's my different color. Whenever I use blue, that's your normal pencil or whatever you're using. You don't have to do that, but I think it's a great idea. So this is a true statement. I'm going to write this in my different color in red. Heptagon, that is what a heptagon is. It's a 7-sided polygon. Statement Q, negative 18 plus negative 17 equals 35. Is that true? No, that is false. It should be negative 35. So this I would write an F next to. That's false. And this should be negative 35. If it said that instead, then this would be true. And statement R, Ottawa is the capital of Canada. You might not know that, but it is. Our neighbors to the north. That is true. I love Canada. One of my favorite countries to go visit. I guess I haven't been that many countries. I think it's 8 at the last I counted. But Canada, just a great country. A little cold in the winters, but great place to visit. I've never been to Ottawa. Would love to go there. Looks like a beautiful city. So, statement A, P and Q. If we're going to write that in symbols, it doesn't say we have to do that, but if you were to write it in symbols, it would look like this and that. So, P and Q. Remember that capital looking A without the line there. That's our symbol for and. So this written out in words, writing out the compound statement, what's it look like? Well, P is this, a heptagon has 7 sides. So we write that all out. And then Q is negative 18 plus negative 17 equals 35. So that's P and Q. That's the compound statement. So I'm not saying whether that's true or not right now. I'm just saying that is the compound statement that they're looking for. So now let's determine the truth value. Is this a true statement? Is this and this true? Are both of these things true? Remember, they both have to be true, or they all have to be true if there's more than 2 for the whole statement to be true. So a heptagon has 7 sides. Yes, that's true. But is it also true that statement Q, negative 18 plus negative 17 equals 35? Is that also true? No. So is this a true compound statement, a true conjunction? No, this is false. So that would be my truth value. I think some good things to write out here. I'm going to use my different color again. I can look at this. I can say that P, that is a true statement, and Q is a false statement. So that makes it easy to determine whether this is a true or false statement. If these are both true, since it's a conjunction, they both have to be true, then the statement would be true. If either one of these is false or both of them are false, then your statement is false. So let's make a little note of that. I'll use my different color again for that. So both must be true with conjunctions. Exclamation point, yes. I think it's worth an exclamation point. I think it's that important. So R and P now. So let's write it out first. Ottawa, that's the R statement up here, is the capital of Canada. And then P and a heptagon has 7 sides. You may be finding you have to write a little smaller with this one. We've got full sentences to write out here. So if you're writing this out in words instead of symbols or without the symbol there, you could say R and P. That would work. So this and this are the same thing, just so we get practice with that. R was a true statement, and P was also a true statement. So we have true and true. A true and true conjunction is true. Both things are true. Everything's true, so that means the conjunction itself is true. And again, I'll use my red here. So both are true. So the conjunction is true. And I'm not going to write these things every time. I'm just writing that for these initially. And that's a not a full sentence there, but I'm just trying to make it shorter for us. So both are true, so the conjunction is true. So conjunction is true. P and not Q, what would that look like? Well, we said back here, the negation of something we can write as like this, not P, tilde, and then a P. So, going too far there. P and not Q would look like this in symbols. P and not Q would look like that. So is P true? Yep, P is true. Is Q true? Yes. And so not Q has the opposite truth value of that. So that means not Q would be true. Q was false. I think I might have missaid that. Q was false. That means not Q is true. Not Q is opposite of that. And so we have something that's true and true. If we write out this in words, let's see what we got. We have a heptagon has 7 sides, and negative 18 plus negative 17. Now I could say does not equal, like that would be the opposite of Q, not Q. So does not equal 35. And so is this true or false? We had something that was true and something else that was true. If they're both true with a conjunction, the whole statement is true. So this one is true. I can say they're both true, so the conjunction is true. I'm not going to rewrite that down again. And then down here, not R and P. So I'm going from symbols to words instead of words to symbols. Not R. Since R is true, not R would be false. It's the opposite of that. And since P is true, I would have true down here. So let's write out what we got. We have not R would be Ottawa is not the capital of Canada. And I've got a bunch of Canadians yelling at me right now, I'm sure, saying, yes, it is. Yes, it is. Yes, it is. It in fact is. So this is a false statement. So Ottawa is not the capital of Canada. It is the capital of Canada, eh? That's more what they're saying. Ottawa is I just totally, I can't even think of the word right now. Stereotyped Canadians. That's what I'm looking for. So totally stereotyped Canadians. So Ottawa is not the capital of Canada. And statement P, a heptagon, has 7 sides. I have some Canadian friends. They do say a, and they say about instead of about. And I'm going to go out and about on a boat. Oh boy. Let's see. This is false. This is true. They both have to be true for the conjunction to be true. So that means the conjunction itself, the whole statement altogether, is a false statement. Now moving on to disjunctions. Oh, look who it is. It's going to be our neighbors to the south now. Welcome to Mexico. So we have a disjunction is true when any of its statements are true. So with a conjunction, all the statements had to be true. A disjunction, any of the statements true makes the disjunction true. So let's see. Example 2. Use the following statements to write a compound statement for each disjunction and then find its truth value. So we have P, negative 19, greater than or equal to 18. I'm going to start like I did before here and just list the truth values in my different color. So is this a true statement? Negative 19 is greater than or equal to 18? No, that's false. You could say negative 19 is less than or equal to 18. That would be a true statement, but you can't say this. So statement Q, an equilateral triangle has 3 congruent sides. Yep, that's what makes it equilateral. That's a true statement. And Acapulco is the capital of Mexico. My Mexican friends are yelling at me saying, no, it's Mexico City. And that is correct. So it's Mexico City. And this is a picture of Mexico City. It looks like another beautiful place I'd like to go visit. It's a pretty highly populated place, though. I hear there's 8 million people in Mexico City proper, and I think if you go to the outskirts and the suburbs, it's like 20 million something. I think there's a lot of people that live there, so it might be a little crazy, a little hectic if you do go visit there. But again, it still looks beautiful, I think. So let's see what we got. P or Q. So we can write that like this, and it's now not and. And was the A with the invisible mark, horizontal mark there. This is P or Q, so we flip that around and write it like that. So it looks like P, capital V, Q, kind of. So we have P or Q. P is false. I'm going to write that underneath it. Q is true. And if we write out the whole statement, P or Q, the compound statement here, this looks like this. Negative 19 is greater than or equal to 18. Or, instead of and now, or an equilateral triangle has 3 congruent sides. So is this a true statement put together? So this part's not true, but the second part is true. And as long as one of the things are true, you have a true compound statement, a true disjunction. So this is true. And to make a little note, so I'll use extra color for that. So only one needs to be true with a disjunction. Only one needs to be true. With disjunctions. Another exclamation point. I'm excited about that. All right, let's check out this one. So we have P or R. That's what that means in words, from words to symbols there. So P, false statement. I'll write that underneath it. R, also a false statement. If they're both false, none of them are true, then you're going to have, what do you think? Let's find out if you're right. I'm not going to say it yet. I'm going to write out the statement first. Negative 19, and we have this or R. Oops, got to finish writing that there. Negative 19 greater than or equal to 18, or Acapulco is the capital of Mexico. So that's not true, and neither is this. So if neither one of them are true, that means the whole statement is false. And I'll write in my different color here, none are true, so the disjunction is false. And then finally, let's check this out. Not P or not Q. Not R, I mean. So this is not P or not R. Since P is false, not P would be true. And since R is false, not R would be true as well. And if we write this out in a sentence form, it would say something like this: negative 19 is not greater than or equal to, we can put a slash through the symbol there, not negative 19 not greater than or equal to 18. Okay, so that's true. Or Acapulco is not. Could you say isn't? Sure, that'd be fine too, but is not works just as well. Is not the capital of Mexico. So is this true or false? Well, you got any of the statements true makes it true. If they're both true, or if they're all true, yeah, it's definitely going to be true. So you got both statements true. That means the disjunction is also true. And moving on to slide number 4 here. We have conjunctions and disjunctions can both be illustrated with Venn diagrams. I bet you've heard of that before. So Venn diagrams. And for two sets A and B, a conjunction is so when we were talking about conjunctions, we're talking about where they come together, where they intersect. It's the intersection of sets A and B. Now, our book doesn't show you what it is in symbols. At least I didn't see it in there. But it would look like this. It's kind of an A and then an upside down U that's a little wider than normal, and then a B. So we would write it like that in symbols. I may refer to it like that in the future. But again, you might not see that in our book. While a disjunction is we put them together, we bring them together. It's the union of A and B. And we write that as A, and then it's easy to remember union is the capital U looking one, but again, a little wider than what you might write a normal capital U. So A union B. And example 3, the Venn diagram shows the number of students in a school that play in band and play on a sports team. So we got some band members here, some sports team members. Some of them do both. Looks like we got either a lot of students at this school or a lot of really involved students at this school. Perhaps it's a small school, it just has a lot of involved students. That's a good thing right there. Extracurricular activities, how many students play both in band and on a sports team? And so we're looking for things that they have in common, things where they intersect. So this and this, where do they intersect? That's right here. That's this number right here. So these are students in the yellow that play both in band and on a sports team. These students would just be in band, these students would just be in sports, and these students are on both. So we have 73 students are, I guess I'll write down the word students, since I usually am wanting you to write units down or what the thing is with whenever possible with word type problems. So 73 students are playing in both band and on a sports team. That's this number right here. And so I'm going to write this in red because it's not totally necessary to have this on here, so I'll use my different color again. If I were to call this, and I'm probably going to get some laughs out of this, but no, this is not a bunch of BS. We have B for band, S for sports. This would be the intersection of the band set and the sports set. So this is where they come together. For part B, how many students play in band or on a sports team? So here's the difference. This or this, that would be any student in either one of these circles. You could have anybody from this green section or the yellow section or the bluish purplish section. So we have 126 plus 73 plus 89. And that's going to be 288 students. And if you had to write that out in symbols, this is the things that are in either one, this or this. So this would be the union of those. It looks like bus, but this is B union S. Band united with sports. And finally, how many students play in band but not on a sports team? So now we're talking about students just in this green section here, because if they're in the yellow section, they're playing sports as well as playing in the band. So this one, 126, is what we're looking for on this particular problem. So 126 students. And then I'm not going to write this down and what that would be, but if you took a logic course, this would actually be B union, not S, is how we would write that. So stuff that's in B, but not in S. But again, that's beyond what we need to know for this lesson. And finally, a truth table is a convenient way to organize truth values of statements. So we got Jack Nicholson here saying that you want the truth, you can't handle the truth. 1992, Few Good Men, old movie. I think I saw it once. I should probably watch that again. I think it was pretty good. I don't have a lot of memories of it. Have you watched it? I don't know, you can tell me if you liked it in the comments if you want to. So, construct a truth table for each compound statement. So we're going to start off, I'm going to have some things that I'll put in different colors. I think it'll be especially helpful on this first one here. So not P, and remember it's not the A looking one, it's the upside down one, so that's or. So not P or Q. So we're trying to figure out when would these things be true. And you might be saying, well, there's no statements given to me, how can I possibly know? We're going to list all the different possibilities. So let's start off with this. I'm going to write in P, I'm going to write in Q, and then I'm going to write in, I'll make my Q a little smaller here so you can see what values I'm putting in here a little bit better. This will be not P, since that's one of the things I see in this statement, and then this final one will be not P or Q. So you've probably never done something like this before, so just bear tight or hang with me here. Hang tight, bear with me. I think I messed that phrase up there. So off to the side here, let's write this. So this row was step 1. Putting that in. So we have two statements, P and Q, and then we're going to put not P because that's in the statement up here, and then not P or Q is the whole statement. This is where we're going to end up in the end here. So as we fill this out, there's some different combinations, some different possibilities. You could have statement P being a true statement and Q also being a true statement. That's one possibility. They're both true. You could have statement P being true but Q being false. That's another combination. That's another possibility. So again, we're not saying what P and Q are, what the statements are. We're saying for any statement P and any statement Q, if they're both true, then we'll say something else. If P is Q and P is true and Q is false, then we'll have something else. P could be true and Q could be, or P could be false and Q could be true. And finally, they both could be false. So these are our 4 combinations. These are our 4 different possibilities. This was step 2 right here. So again, I'm getting out my different color and I'm designating this as step 2. So I'm just going to write a 2 and say that we list all the combinations. Like list all possible combos for combinations for P and Q. So that's what we did right there. And then step 3 is going to be this column right here, step 3. We're going to fill this out. So we need to think about not P instead of P. So I'm just going to take my values here and I'm going to negate them. I'm going to write the opposite of what I see there. So true and true becomes false and false. False and false becomes true and true. And then finally I'm going to, in step 4, now I'm going to look at not P and I'm going to look at Q, and I'm putting them together with an or in between them. So I'm taking these truth table values for not P and for Q, and I'm applying the or in between them. So or, a disjunction, means that just one of them had to be true for the statement to be true. So do you have one of the statements in this row being true? Yep, we got Q true, so that means not P or Q would be true. If they're both false, then your disjunction's false. If they're both true, or one's false and one is true, then the disjunction is true. So we have 3 true values and 1 false value for not P or Q. No matter what the statements are, we got all different possible combinations listed here. And so this would be a truth table for this compound statement. Let's keep practicing that, because I'm guessing you're probably a little uncertain, or a little not quite confident. That's what I'm looking for. Not totally confident with this yet. So let's do this. I'm not going to write the red stuff as much this time. Remember though that this was or up here, and this is and over here. So we have this time and we have a conjunction. So I would start by writing, since we have P's and Q's in here, I'm going to start writing a P here and a Q here. And then we're dealing with not P and not Q. So I'm going to write not P and not Q there. And I can use the same values I started with over here. So I've got 4 combinations when I have 2 statements. I've got true, true, I've got true, false, I've got false, true, and I've got false, false. If you put those in a different order, that's okay, but you got to have all 4 combinations listed. And then from there, negate P and negate Q. So I'm going to take this column and do the opposite. False, false, true, true. And then this one becomes false, true, false, true. And now we are looking at not P and not Q. So that's going to go in this last column, not P and not Q. So take these values right here, put them together using the word and, thinking about conjunctions where they both have to be true for the statement to be true. The only one that's going to be true then is this bottom row. That's the only one where both P and not Q are true. These other ones, since they're both not true, that means the whole statement is false. And then finally, you might see something like this. You might see 3 statements in there. So I'm going to put P here, Q here, and I'm going to put R over here. You'll see why I put that here instead of over here in just a moment. But in the middle here, I want to put P or Q, because that's what I have in parentheses here. It's kind of like order of operations in algebra or in just arithmetic. We're doing this before this. So wherever the parentheses are, do that first and then apply the next thing. So P, Q, R. We have how many combinations with something like that? I'm going to write this. Oh, let's see how I want to do this. I'm going to go like this, this, and this. So I'm trying to show you that P, Q, and R, where are these values coming from? This is step 1. We're going to list all possible combos. I guess it's step 2. We're filling this out first. But then that's step 1. So this is step 2, listing all the possible combos for P, Q, and R first. Yeah, you could say second if you wanted to. If you wanted to say this, then this row is first. I'm not going to get too caught up with that. So I've got P, make my parentheses a little better there. I've got P or Q and R. So let's do this now. Let's fill out P, Q, and R columns. So I've got one possibility is that they're all true. That's the easiest one probably to think about. So with this first column, I know P would be true half the time and false the other half of the time. So I'm going to start by filling in the rest of that column. And then I'll go after that with Q. I could have true and true and true. I could have true, true, and false. I could have R being false. Or I could have Q being false and R being true. Or I could have both Q and R being false. So that's one possible combination. Or that's 4 possible combinations, I should say. So we've got all these. And then I can repeat what I just did with P being false instead. So I could say true, false. And then I could say false, true. And I'm sorry I missed one there. Let me go back. That's why we use pencil, right? Yeah? Okay. So true, 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 false, false, true, and both Q and R being false. So it looks like we have all the combinations then. And from there, we can figure out, okay, what's P or Q? And remember with P or Q, just one of them has to be true for the statement P or Q to be true. So look for ones where they're both, I would say look for ones where they're both false. Those are the only ones that are going to be false. Everything else will be true as long as you have one of the statements being true. With or, the whole statement is true. And then from there, now we're going to look at this column and this column. So P or Q, we're going to put that together with R. So P or Q is this first part, and R is the second column. And with conjunctions, both have to be true. So now I'm going to look for when both of them are true. I know those are the only ones that are going to be true. And here's another one where they both are true. And the rest of these would be false. There's one more double truth right there, making the statement true. The rest of these have at least one false, making the whole statement, the whole conjunction, false. So as always, go back and review what you need to. Look at those extra examples in your book. I made different examples, and I always do this. I always make different examples here than what are in the book, but they're similar examples to what you have in the book if you're one of my students. Go back and review if you need to. Again, there's a lot of new stuff here, not particularly hard stuff, I don't think, as long as you practice it enough. Math is just like any other thing that you got to work at to get better at. You got to practice to get better at math. Definitely applies to math as well as most things in life. And so make sure you know what these terms are now. If you don't understand the terms, review the video, ask me questions in class. If you're one of my students, comment on the video. Just make sure you get it down. All right, that'll do it for this one. We've got 2.3 coming up next.